Hi everybody, so today we are doing topic 9R, which is one-step inequalities. So our learning goal for today is I can write and solve one-step inequalities by using inverse operations of addition, subtraction, multiplication, and division to solve for missing variables. Please pause this video right here so that way you guys have time to write down the learning goal on your note sheet. Alright, so let's talk about some of the vocabulary that we're going to see today. So, first off, we have inequality. This means that both sides of our equation are not equal. So, since they're not equal, we cannot use an equal sign in our equation. So all of last unit in topic 8, we had expressions that looked like this, or equations that look like this. So v plus 2 equals 8. And so we knew that this part of our equation had to equal 8. So something plus 2 equaled 8. To solve that, we subtracted 2 from both sides. These canceled, and that left me with v equals 6. So, I knew that v had to equal 6 because I knew my equation had to be equal to 8. Well, in an inequality, this part of my equation may not equal 8. And depending on the sign that is used, it might equal something less than 8, something greater than 8, or something less than or equal to, or something that's greater than or equal to. So in order to figure this out, we have to know what our signs mean. So whenever we see a sign that looks like this means less than. Whenever we see a sign that's flipped, this means greater than. All right, a less than sign that's over a line, this means less than or equal to. A greater than sign that's over a line means greater than or equal to. So, just to refresh, these symbols that we just went over right here, these are our inequalities. So instead of using an equal sign, we are going to be using one of these 4 symbols. To help us solve for our missing variable. So, you should be writing these symbols and their definitions as well as the vocabulary on your work page that was handed out to you. If you need to pause the video right here to catch up, I would definitely do so. Alright, so let's start solving some one-step addition and subtraction inequalities. So, this is a map of a light rail, which is very similar to a subway if you've ever ridden one of those. These maps are listed a lot in New York, Chicago, stuff like that. Mostly cities where you ride subways. So, you have 28 minutes to get from West Harrison, to Mason University. If the light rail takes 9 minutes to go from West Harrison to Liberty Way, how long will it take for the light rail to go from Liberty Way to Mason University? So, let's go through this one more time. It said that it took to get from West Harrison to Liberty Way, it took 9 minutes. And to get from Liberty Way to Mason University, we don't know. So whenever we don't know the value of something, we always put a variable. So I'm going to put an X. And their whole destination that we want to get to is from West Harrison to Mason University. And to go that whole way, we know that you have only 28 minutes. So you have 28 minutes. That means that you don't have any more than 28 minutes. It can equal 28 minutes, but it can't go any higher than that, or else you're late to this art class. So that's a big part of the story, that you only have 28 minutes, or else you're considered late. So let's set up our equation now. So I know that I have 9 minutes to go from West Harrison to Liberty Way. And then I have to go X amount of minutes to get from Liberty Way to Mason University. So 9 plus X has to equal no bigger than 20 or no longer than 28 minutes. So this part of my equation has to be less than, or it could be equal to, 28 minutes. So I can't go higher than 28 minutes. So it has to be less than or equal to 28 minutes. Well, now that I have my equation, I can solve this. And I solve it the same way that I solved everything in topic 8. So if you still have that little piece of paper that you used on your test, I recommend pulling that out now. So just like we solved in topic 8, we're going to draw the line. And whatever we do on one side of the equation, we still have to do it to the other side of the equation. That part has not changed. The only thing that has changed would be our equal to sign. Okay? So right now I'm adding 9 minutes to X. So I have to do the inverse. And the inverse is subtraction. So I'm going to subtract 9 from both sides. So when I do this, my 9's cancel, and I'm left with just my X. I bring down the same inequality sign that I used before. Do not bring down an equal sign. There's not an equal sign up here. This is a less than or equal to. So I have to bring down a less than or equal to. Now, 28 minus 9 gives me 19. So my answer is that X is less than or equal to 19 minutes. So I have less than 19 minutes to get from Liberty Way to Mason University. All right, so if you have not been writing down these notes as you went along with me, I need you to pause the video now to copy down the notes that we took. Okay, so these need to be on your paper, and I am checking them tomorrow. All right, so we're going to start solving some one-step multiplication and division inequalities. So these are still one step, and we still solve them the same way that we solved topic 8 equations for our missing variable. However, the only thing that's changed is our equal sign. Instead, we are replacing that with an inequality symbol. All right, so a city's bus costs $3 per ride. There's also a monthly pass available for $65, and that allows unlimited rides for the month. How many times per month must you ride the bus for the monthly pass to be a better deal? So I want the monthly pass to be the better deal. That way I can see how many rides I would have to take individually to make the monthly pass a better deal. So in order for the monthly pass to be the better deal, I know that my $3 per ride option has to cost more than my monthly pass. So when I write this equation or this inequality, I have to have my $3 per ride cost more. So let's write this out. I know that it costs me $3 per ride. Well, I don't know how many rides it's going to be. So when we don't know a value, we put a variable. We put an X or a letter. And that's just the placeholder for us. That way it gives us time to solve it. All right, so 3X, so $3 per ride, has to be more expensive than my monthly value. So if it's going to be more expensive, I know that I need to use a greater than sign, not a greater than or equal to sign. I don't want them to be the same. I want my individual bus ticket to cost more than my monthly pass. That way I can see how many rides would make the monthly pass a better deal. So I'm going to use a greater than sign. And this is greater than my $65 monthly pass. So just like whenever we solved in topic 8, we do the inverse operations. So I'm going to draw my line. And right now 3 is being multiplied by x. So I have to do the opposite. And the opposite of multiplication is division. So I am going to divide by 3 on both sides. 3 divided by 3 gives me 1. And 1 times x just leaves me with x. So I'm just going to bring down my variable. As I bring down my variable, I'm also going to bring down my inequality. And then I'm going to do 65 divided by 3. So 65 divided by 3 gives me 21.6 repeating, or 21 2/3. Well, I can't go on 2/3 of a ride, right? I either buy my ticket and go the whole way, or I don't ride the bus at all. Like, I can only go 2/3 of the way. So when I write my answer for my inequality, I have x is greater than 22 rides. So I had to round up because I couldn't go 2/3 of a ride. I couldn't go 0.66 of a ride. I could only go the entire way or no way at all. And 0.666 will round up to 22. So I have to ride 22 times in 1 month in order for the monthly pass to be a better deal. That's what this is telling me. So if you have not been writing down this example and solving it with me, I need you to pause the video right now to catch up on your notes.